Hello everyone, welcome back in another video. I am Vaibhav. Today, date is 3rd of October 2022, and in our today's video, we are going to see joins in SQL. Before seeing the joint, we see the SQL. SQL is nothing but it is the one kind of a database. It is a database which is stored data in the form of rows and columns. So when we have to read data from that database, that time we have to throw a query toward that particular requirement. That means we are run the query in our SQL. Suppose there is a one table of employee, that table containing different attributes like that employee ID, employee name, and employee address. So from that table, I have to find out the address of the particular employee. So that time there is a one unique key are required in our table. So in that table, the employee ID is our unique key. So we can easily write the query to find out the particular name of that employee and address of that employee by their employee ID. We can simply write that query like select star from employee. That means that table's name employee, and we have to find that particular ID. That means we can write as select star from employee, where employee ID is equal to 1. So we can get the employee which employer having ID 1. We get the address of that employee. And in another case, we have one more table. In that table, we have to that table consists a data of departments. That means that employee working within a department. So we have to we are create two different tables for store that data. That means if we are contain all data within a one table, that time the department name, that means any department can have a one to many relation. That means one department can contain a multiple employees. That's why if we are not creating separate table for that employee data for that particular employee, we have to write that department and their department ID in front of their data of employee again and again. That's why for reduction of for memory reduction of consumption of memory in our code, we have to use that two different tables for that case. Suppose we are creating another table for the departments. So that department table can contain a department attributes like a department ID, department name, and the employee ID. So in that case, there is a one attribute is a common within that two tables. That attribute is employee ID. So we must have at least one attribute similar between the two columns for performing a joint between that tables. Here comes our joint concept, because we have to find the data or fetch the data which are written within two or more than two tables by using one query or by using one logic. That's why we are using a joins. There are different types of joint we can discuss. Before that, we the for joint there are some important rules are there. That rules like each table should have any unique key. That means there must be a any primary key. Primary key means the non-duplicate key. That attribute does not have any duplicate or repeated value or repeated attribute. So that is the first rule. And another rule is that the each table, suppose we have to make a relation between the two tables, or we have to make a join between the two tables. That case, one table should contain a primary key within that table, and that primary key works as a foreign key for the another table. So in our example, that our employee ID is works as a primary key in employee table, and same that employee key can work as a foreign key in the department table. So that is the two important rule for creating a join. So we need a join because suppose in that scenario, I have to fetch the department ID of particular employee. That means I am having a uh, I need a employee name and the department ID of the particular employee. That time, suppose I am having a employee ID as a 2, I can find out easily that employee ID, find out easily the name of that employee from my employee table by using their employee ID. But when I have to identify the department for particular that employee ID, that time I have to create a join between that two tables. So there are different types of joints are there. Uh, the first joint is a inner joint. Another joint, second joint is the left outer joint. Third joint is the right outer joint. Fourth joint is the fully outer joint, and the last one, that is our self joint. So we can see all those joints one by one. So initially, first one is the inner joint. Inner joint means, suppose we are creating a that two table of employee and company. That employee table can contain the employee ID, employee name, employee address, and another table can contain attributes like like their department ID, department name, and that employee ID. That employee ID is a same within that two tables. So that time, that table can contain some unique employee ID. Suppose there is employee ID as 1, 2, 3 for the Somu, Gomu, and Some, and their addresses are there. And in another table, they containing a department details. So department ID, suppose D1, D2, D3, and the department name, suppose ID, IT, IT support, and uh, backend support. So these departments are there, and then one more attribute is that employee ID, which is same as our employee table. So when we are implementing a inner join, that time when we finding the data from both that table, that time we able to fetch only that data which is similar between that two employee ID attributes, because that our employee ID is works as a foreign key and also works as a primary key. So the same data which is same employee ID that containing the data, we can able to fetch that data by using a inner joint. After that, the next joint is a left outer joint. That means, suppose in our inner joint, there is a three employees as we seen, Somu, Guma, and Somya. So these three employees are having their department, but suppose in that department section there is a ID like a D1, D2, and D4. That means there is a not any D3. That means the employee number as a 1, 2, and 3, but in our uh, department section there is not any employee 3 is present. There is a data department data is stored for the employee number 4. That number is not present in our employee table. So that time we are able to fetch the data only for employee number 1, 2, and 3, because that numbers are present in our both the tables. After that, the left outer table is, that means the our primary the attribute which are containing our primary key, we get the all the data which is stored within that student table. That means if we are finding the name of we have to finding the name of all employees from employee student by using a left join. That time we get the all name of that employee, and we are finding the particular department for that employee names. That means the complete employee names are comes. That means suppose there is a 5 employee names are there, that 5 employee names are come within our output. But in a another table, in our department table, suppose there is only 4 departments are present, it shows the particular departments as per their allocation. And if there is not any department is present for the particular name, it directly show as a null. That means by using a left outer join, we can fetch the complete data of our left table and get the attribute presence only with presence equal same as a data table 1. After that, the next join is a right join, right outer join. Right outer join is the vice versa of a left outer join. That means it is the opposite to the left outer join. In left outer join, the complete data within our table 2, that is our department table, that shows the complete department list. That means it shows the D1, D2 and D3, the complete department list. But if suppose there is a only two employees names are present within that, within our employee table, that time it show the total employee employee I total department ID as a D1, D2 and D3, and only shows the presence name in the our employee table, that is the Somu and Gomu. And if there is a one more department is present, that time in the section of name or in the section of employee table, it shows the null. That means it show the complete data within the table 2, that means the in the right table, and in left table it shows that data which is only equals to the data which is stored in our right table or our department table. After that, the fourth one is the full outer joint. That full outer joint means it shows the complete data which is stored in our left table and right table. That means our table 1 and table 2. That is our employee table and our department table. That time the data which is having same employee ID, that means the employee ID present in our employee table and that employee ID present in our department table, it show the both the data which are having same employee ID. But if there is a if there is any condition, the employee name is present but there is a not any department allocated for the that particular name, and vice versa, the department is present but not any employee is assigned for that department. So in that case it shows all those data, but in that case if there is a any vacant place is there, that means any not allocated place, as we see, that time it directly show the null value. That means there is a not any presence of value, it shows the directly. After that, the last one, our joint type is the self joint. Self joint is present in the present in a one table. That means we no need to the create that joint within a two table. We can create that joint within a one table. That means suppose any management system table is there, so that particular there is attributes like employee ID, employee name, manager ID, and manager address. So in that case, the whole complete number which are present in the our employee ID are a primary key. That means these are a unique key. But if we are seeing in a manager ID, that time that numbers are repeated when there is the same manager is present for another employees. That means the actually manager is also an employee. That's why the employee ID sometimes may be a chance that similar as a manager ID. So that means it is the interrelation between the table. That's why we call that joint as a self joint. So that is the overall about joints in SQL. Thank you.